Hi, welcome back. In this video, we are looking at simplifying rational expressions, okay? And remember, rational expressions are just fancy fractions. So you should just think it's the same as reducing or simplifying a fraction, okay? So the way that the textbook I'm using illustrates it is if we have a times c over b times c, that's the same as c over c times a over b. Well, anything divided by itself is 1. So 1 times ab, it just equals to ab. Or, the way I look at it, is if we have a times c over b times c, we have a c on the top and the bottom, we can cancel it, and we're left with a over b. I'm a huge fan of the cancellation technique when it comes to multiplying fractions. Okay. So let's look at an example real quick. Okay. 15 over 20. Well, they have a common factor, which happens to be 5. So I'm going to divide the top and bottom by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. And that's my answer. Easy peasy. Okay. Now, our next example is two factored quadratic formulas, or quadratic expressions, one over the other, okay? But remember, when it comes to multiplication, as long as we have one on the top and one on the bottom, we can cancel. So I have this guy on the bottom and the top. They are joined with multiplication, so I am allowed to cancel them out. Okay, so we end up with x plus 5 over x minus 3. Okay, now we have nothing left that is joined in multiplication. So if I wanted to cancel anything, all of my terms would have to have something in common because they're joined with addition and subtraction instead of multiplication. Okay, so that's the difference. If there had been addition or subtraction in between these, I couldn't have done this cancellation. Okay, that's a very important thing to keep in mind. All right, let's look at a couple more examples. Okay. A couple. I have 5. 5 more examples. Okay. The first one we have is a squared minus a minus 6 over a squared plus 5a plus 6. So now we have two quadratic expressions. We have to factor each one before we can cancel anything. Okay, so neither one of them has anything up front. So it's just going to be a, has to be a negative 1, so it's going to be minus 3 plus 2. Because 2 times negative 3 is a negative 6, and a negative 3 plus 2 is a negative 1. Okay, and this one down here is going to be also 2 and 3, but they're both plus, so it's going to be plus 3 plus 2. Because 2 times 3 is 6, and 3 plus 2 is 5. Okay, so now I have an a plus 2 on the top and the bottom. So as long as I have one on the top, one on the bottom, I can cancel. And then I am just left with a minus 3 over a plus 3. Okay. Next example. We have y squared minus 4 over 2y plus 4. Okay, we still need to simplify, factor, whatever. So here we have a difference of squares. So it's going to be y plus 2 times y minus 2. And this, I can factor a 2 out. So it ends up being y plus 2. Now I have a y plus 2 on the top and the bottom. So I can cancel. And I'm left with y minus 2 over 2. Okay? So we're starting to use everything that we've been learning the past, what, 2 chapters now? What we've learned previously this semester, we are applying now. Okay? And we will continue to do so. Okay. Next example is x cubed minus 27 over x minus 3. The top is a difference of cubes. So it's going to be, if you recall, to find out which the signs are, it's same, opposite, positive, SOP, standard operating procedure. So it's going to be the first minus the second, so x minus 3. And then the first one squared, so x squared. And then the 2 times each other, so 3x. And then the second one squared, so 3 squared, which is 9. And then over our x minus 3. Well, now I have an x minus 3 on the top and the bottom. I can cancel them out. What's left on the bottom is actually a 1. And anytime we have something over 1, we consider it a whole number, so we don't have to leave it over 1. We can just get rid of that and leave it as is. So our answer for this one is x squared plus 3x plus 9. And this polynomial cannot be factored anymore. If you can factor it again, I would recommend it. Because you can always leave your answers in factored form. If you have like 2 binomials times each other left over as your answer, you don't have to multiply them. You don't have to do that extra bit of work. Okay. Now we have 8 plus k over 16. Okay. 8 and k are joined with addition. So remember when I pointed out that when things are joined with addition or subtraction, then you have to find something in common with every single term in the entire problem, right? So 8 and 16 have something in common, but k has nothing in common with them. And then 8 and 16 don't have a k, so my 3 things here do not all have something in common. So I cannot simplify it anymore, so it's just already simplified. And I don't have to go any further. This is a tricky one. You will be tempted to take out an 8 from the 8 and the 16. But you would also have to take an 8 out of the k, and there isn't one, and so you can't take an 8 out of anything. Excuse me. Okay, so be careful on ones like this. When we're not joined with multiplication like we are here, we can't cancel top and bottom. Okay? All right, I'll shut up. All right, we got one more example. It looks daunting, but it's not, I promise. Actually, it's one of my favorites. It's one of my favorite kinds of problems. So, we have this ugly thing. But if you look, the top has 1, 2, 3, 4 terms. The bottom has 1, 2, 3, 4 terms. And when we have 4 terms, we can do factor by grouping. And I like factor by grouping. I think it's the easiest one there is. Okay? So, I'm going to factor by grouping. And we're going to have take an R out, take an S out. Pay close attention to the signs, okay? Because they look the same, the terms are the same, people are tempted to just cancel the whole thing and say, oh, it's the same, top and bottom. But they're not, because these are not the same, okay? So be careful. So let's see, for the bottom, again, take an R out, take an S out, a negative S, we get P plus Q. And then we finish up our factor by grouping. And if you notice, there are no numbers in this problem. But does it matter? Has it mattered at all since we've started? No. The process still applies. It's still the same process. Okay. Doesn't that look so much better? So now we have r plus s times p plus q over r minus s times p plus q. So we have a p plus q top and bottom, so we can get rid of that. So then all we're left with is this here. So our answer is r plus s over r minus s. And we can't simplify this any further. All right, and that is the last example I have for this, for the simplifying rational expressions. Okay, so thank you very much for watching this video, and I will see you in the next one.